Hi everyone. Thanks for tuning in. I hope that you're all doing well and that you're staying safe out there. Um, I hope the semester is going well and that all your classes don't suck. Um, so today, last lecture we went over Pascal's wager. So today we're going to be talking about Pascal's wager again, but from a different angle, from kind of a disagreement point of view. Um, a few things. Don't forget that your paper proposal is due on Tuesday. Be sure to reach out to me before then if you're not sure what to write about. And sorry, I had to pause for a second. And I don't remember what I was saying. Oh, yeah. Reach out to me if you're not sure what to write about. Make sure you turn it in by Tuesday at your scheduled class time. And yeah, get started on your papers if you're able to. They're due October 15th, I think. Yeah, about a month from today. A couple days less than a month from today. Anyways, so, you could write about this that we're about to talk about if you wanted to. I'm not sure if anybody is super interested in probability, but if you are, then this would be definitely your wheelhouse. Let's see, anything I should clarify about Pascal? This would be when I would ask questions. I've graded some of the critical summaries. There didn't seem to be any super big misunderstandings about the Pascal's argument. It's pretty simple. It can be more complicated, as you can see from this other paper that we're reading. You can take it to be a complicated argument, but at its most simplest level, it's just that if you believe in God, then you will either gain infinite happiness forever, or you'll lose nothing. So you should probably believe in God. That's the simplest version of it. So, the philosopher we'll be talking about today is Alan, and I don't know how to say his name, but it's Alan Hayek. Actually, it's probably Hayek. Probably, sorry. There. He is alive now. So he was born in oops. You can see that? In 1962, and is alive today. He is Australian. I honestly don't know too much about him, except that he's Australian, he's a professor at Australian National University, and that his interests are probability theory and philosophy of religion. So, his writing on Pascal is his most famous stuff that he does. So, this is his thing. So, now keep in mind, you don't really have to know everything about decision theory and probability. Don't worry about all of that. Just try to pay attention, know what's going on for the most part, and be able to summarize this. That's all you really need to know how to do. So, we'll just kind of go through the paper. It's a little complicated in some areas. It might be less complicated for you if you love probability and love statistics and stuff like that, then this is probably easy for you, but I know probably not a ton of people are like that. Maybe I'm weird that it's not really my thing. So I'll just kind of I'm not gonna give too much detail because you don't have to know every single detail. I more so just want you to understand the gist of his argument. So we may go short today because after reading it again, I was like, this is kind of a lot a lot of stuff. So we might just boil it down and keep it simple for the most part. Okay, so he starts the paper by giving an example. He starts at... Oh my gosh, my phone is actually blowing up. Okay. Oh my gosh, it's the same person, so I'm not popular or anything. Let me chill. Okay, sorry. So, anyways, he starts with, imagine that you're entering a casino, and that there's a bunch of gambling games, and money. And the first game or whatever is simple, that if you win, you will win $1. If you lose, you will lose $2. Then the decision theorist would ask the question, should you play? You can't see that at all. Sorry. Should you play if there's possibility of either winning $1 or losing $2? The assumption is that you should not play. So, if these are your options, hey, this could be practical. If you go to a casino ever again, if the coronavirus ever dies, then think about your philosophy class and if this is an option. The answer is that you should not play if that's the case. So, this equals don't play. Because the consequence outweighs the reward. And we're looking for good chances of winning some money. So, in this case, don't play. Now, he suggests that what if there is happy hour? In a happy hour, you either win $1 if you win, or lose $1 if you lose. If this is the case, this is clearly an improvement over the first one. So, this is way better than this. Because it evens out. So, if I play and I win 50% of the time, I will break even. I won't lose any money. And with the other one, if I lose 50% of the time, then I'm losing quite a bit of money. So, now you can say that the game is fair. It's fair and an improvement. Oh, you can't see that. That's fine. So, this is a much better deal to you. You could either rationally choose to play the game or rationally choose to turn it down. It's like a 50-50. So, it's kind of up to you. The first one, rationally, you should not play. The second one, rationally, you can play or you don't have to. Your choice. So just in this little scenario, we have engaged in decision theory. And let's go ahead and define decision theory. We love definitions. Keeps us all on the same page. Okay, so decision theory is an account of how probabilities and utilities, also known as payoffs, associated with your various options, Together determine what is rational for you to do. Okay, so let's get this in view. Kinda. Okay, so decision theory is an account of how probabilities and utilities, or payoffs, associated with your various options together determine what is rational for you to do. So we're using probability to determine rationality in a given circumstance. So, let's see. Pascal takes this idea of decision theory and he wraps his theory for the existence of God up in decision theory. He uses decision theory to show that it is rational to believe in God. So, that believing in God is a basic belief that we are granted. It doesn't. So this is not a proof for the existence of God. It's just saying that believing in God is the most rational thing. I lost my marker. So, Pascal presents the existence of God as a decision problem and solves it with the same decision theoretic machinery as the casino example that we had. So, just like we did in the first case of the casino example, you shouldn't play. It is not rational for you to play. And then in the second one, it is rational for you to play. Pascal is using that same line of thinking to explain why it's rational to believe in God. So, just something I found interesting was that Pascal's wager was the first well-understood contribution to decision theory. So, even though Pascal wasn't like this probability king, he was one of the very first to use decision theory. So it's interesting, and it also makes sense since he was like a genius apparently. So if we recall, what Pascal is trying to do is explain whether we should wager that God is or wager that God is not. And then I'm going to call him Hayek because I'm going to have to say the name again. So I don't know if that's how you say that name, but that's actually, hold on. Okay. There's that famous person named Salma Hayek. It's not spelled the same. I was hoping that if I looked it up, it would be spelled the same, and then it would be like, yeah, that's how you say it. But anyways, I'm gonna call him Hayek. So if you know how to say the name, then just ignore me. So he just explains what Pascal is arguing, which this is a good way to see an example of somebody writing a philosophical paper. He gives a summary of what the philosopher originally wrote that he's talking about before he goes into his argument. So first he explains just like decision theory. So that's like just kind of defining in the first part of the paper. Then he moves to summarize Pascal's point from his paper. And then he moves to explain what decision theory is in detail, and then he gives his arguments. That's a great way to write your paper. So just seeing how people write and noticing it, taking note, should be helpful for you in your paper. So now we get to the specifics of decision theory, which you might not care about at all. It's fine. So remember that utility is also, we could call it like a payoff, the outcome. So he kind of gives little charts, which is helpful, I think, to kind of visualize what's going on. So, okay. So we get the original casino example. We have this decision. We have heads, tails. We have play, don't play. So, play, we have heads, we have -2. So, -2 is when you, -2 is when you lose, that does not look like a 2, is when you lose $2. And 1 is when you gain $1. And 0 is just when you don't play. You get 0. Then you get the happy hour decision, which is a little bit different. We change this one to -1 instead of -2. So this is how you can write it out in like a more diagrammy way. So in this case, this is where we see that this is the more rational game to play. And we get an example of dominance reasoning. And dominance reasoning actually has kind of a long definition, so I'm not going to write it out, but I will read it to you. So here is dominance reasoning. Given two actions A1 and A2, say that A dominates A2 if each outcome associated with A1 is at least as good as the corresponding outcome associated with A2. And my dogs are being annoying. 2 seconds. Okay, I'm back, sorry. So, let's see. A1 dominates A2 if each outcome associated with A1 is at least as good as the corresponding outcome associated with A2, and for at least one state, A1's outcome is strictly better than A2's. So, put it simply, the principle of rationality is choose the dominant action if there is one. So, playing the happy hour game dominates playing the original game because it's an improvement. It's a better option. So if you have those two choices, you should not play the regular game, you should play the happy hour game. And that's an example of dominance reasoning. Which is important because that's what Pascal ends up using. So, here we get some expected utility. And utility is payoff, so expected payoff. So we get original game, we have half times 1 plus half times minus 2 equals -1/2. So this -1/2 is less than 0. 0 is the utility of not playing at all. So not playing equals 0. So if you play, then your expected payoff is less than if you just didn't play at all. Now, the happy hour game is, as we've said, better. So you get 1/2 times 1 plus 1/2 times -1 equals 0. So now we're at the same utility as if we didn't play. So you're not going to lose anything. So now the game is fair. Fair not so fair. So if we're going to play a game, if we're going to gamble, then we want the utility to be 0 or greater. In that case, it's rational to play. So, since we have these two options, we should obviously go with the second one. That one dominates. So now we have to think about Pascal's argument in light of all of this. So, let's go ahead and erase. So, we are, decently familiar with Pascal's argument. So, I'm just going to go right in. So, we have God exists or God doesn't exist. And then we have wager for God and wager against God. Okay, so that's our chart. So that's supposed to resemble the chart we did earlier with the original versus happy hour gamble. So, according to Pascal, this is what he's doing here. If God exists and we wager for God, then we gain all. If God doesn't exist and we wager for God, you lose nothing. Lose nothing / status quo. So things stay the same. If we wager against God and God does exist, then we get misery. And then if we wager against God and God doesn't exist, we don't gain anything in that case either. So, status quo. So, this is kind of what Pascal is doing here. So, this is an example of dominance reasoning. Obviously, if we lay it out like this seems to be the better choice, the more rational thing to choose, because your utility is going to be more than the utility of wagering against God. So, let's see. Okay, I just want to make sure I'm not missing anything before we go on to the next thing. So then we have to think about expected utilities. What are they supposed to be in this case? Pascal says that the expected utilities, the unit of utility in his case is a life. So he argues that if you had only to gain 2 lives instead of 1, you might still wager. So if you could gain a life, gain 2 lives instead of just 1 life, then you might wager. And you would be imprudent when you're forced to play not to chance your life to gain 3. So if you have the chance to gain 3 lives, then you should definitely wager for God. So then we have, say, we are calculating the utility, and there's 2 lives, then we get 1 life. Say we're calculating the utility for 3 lives. We get 1.5? Yeah, 1.5 lives. So his argument is that a gamble that pays infinity with probability half has an expected utility in lives of infinity. So for him, he's thinking an infinitely happy life if you wager for God. So you have half times infinity equals infinity. I mean, you can't half infinity. So this just shows that you need to play this game. This game of choosing whether God exists or not. So, this shows that no matter the expected utility of wagering for God, this means that the expected utility for wagering for God is infinite, no matter how unlikely it is that God exists. So this number, we're using half just as kind of a stand-in. Say it's a 50-50 chance whether God exists or God doesn't exist. Then you get infinity as your outcome. Say that there is 0.000001 chance that God exists. Multiply that by infinity and you still get infinity. So it doesn't matter how unlikely or how likely it is that God exists, because either way, the expected utility is infinite. So, the answer to this question of what wagering for God is worth is an infinite amount. So wagering for God, according to Pascal, is worth an infinite amount. So he says that this is an interesting problem that Hayek points out in Pascal's theory. Pascal says, I am forced to wager and am not free. I am so made that I cannot believe. What then would you have me do? So he says, I'm forced to wager. And at this point, he kind of creates a problem for himself because his whole argument is based on decision theory. So it's supposed to be a choice. If it's not a choice, then his argument might not really work. Because if you can't believe in God at will, then you're not making a conscious choice. So how is this a decision problem? So that's an interesting objection to Pascal. And also, another thing that he points out is that Pascal says you have to suppress your passions in order to believe, basically. Because your passions are the only thing that's going to tell you not to believe. And he almost makes the argument that you have to become less human. You have to become more like a beast in order to believe, because you have to suppress your passions, your emotions, your rational thinking, all the above. And to some, you would see that and think that if God isn't real, then that's a lot to sacrifice for no reason. So that's another possible objection. So there is a little tension in Pascal's argument. So here we need to write out Pascal's argument premise by premise, because Hayek is going to talk about some possible objections. Alright, so premise 1. You should choose the action of maximal utility if there is one. That is the premise he's starting from. Then you get premise 2, which is the probability P that God exists is positive. Alright, then premise 3. Did I just call that premise 3? Anyways, that was premise 2. I can't remember if I said 2 or 3. This is premise 3. The decision matrix which is like the decision chart, is as follows. where f1, f2, and f3 are finite utilities. So, make our chart again. God exists. God doesn't exist. Wager for God, wager against God. We get God. If God exists and we wager for God, then there is an infinite utility. If God doesn't exist and we wager for God, finite utility 1. Wager against God, God does exist, finite utility 2. And God does not exist and we wager against God, finite utility 3. All of these end up being equivalent, except when you wager for God and God does exist. So, then we get conclusion. Conclusion 1 is that wagering for God has infinite expected utility. That's after we make our chart. Let's see. Okay, sorry about the third pause since we began. Okay. Wagering for God has infinite expected utility. We'll call that EU. And we get that from the chart. Conclusion 2 is that you should wager for God. Easy as that. So, that's kind of his big argument. Premise 1, 2, 3, conclusion. Easy as that. So then, all that Hayek has done so far is shown us what Pascal is doing using the decision theory, which is interesting in and of itself. So he shows some objections that can be made, but he's not actually, the purpose of the paper isn't necessarily the objections. It's to lay out the decision theory that Pascal is using, and then to give examples for why it might not work. So, this objections section, that rhymes, could be really beneficial for y'all because it points to specific premises and says this premise is where the problem lies. So if you're objecting to someone's argument, you want to point to a specific part of their argument where it falls apart. So the best way to do that is to look at the argument premise by premise or step by step and say, okay, you could say the first premise is good, second premise is where the problem is because this. So he gives an example of an objection for each premise. So objection to premise 1 is that there could be other factors besides expected utilities that determine the worthiness of the choice. So we are strictly looking at expected utilities in this argument because wagering for God and God existing has an infinite expected utility. Pascal takes that as being the reason that you should wager for God. So the objection to that is that there could be other factors other than just expected utilities. So Hayek gives the example of variance, or a measure of how spread out the utilities are. So high variance gambles are risky because they because there's a disturbingly high probability that yields outcomes far worse than their expected utilities. So in some cases, getting less than your expected utility is guaranteed, but you still want to take the bet. So there are some cases in which a high expected utility isn't the end-all be-all. So that is one objection to premise 1. An objection to premise 2 is that an atheist could insist that the probability that God exists is absolutely 0. Because if you recall, for this argument to work, the probability that God exists has to be greater than 0. And it can be 0.0000001 chance that God exists, and Pascal's argument still succeeds. So you have to be a very strong atheist that says there is absolutely 0 chance that God exists. And if you are able to say that and make that claim, have arguments for that, then that's a hole in Pascal's argument, because it has to be greater than 0. So that's another possible way to object to Pascal. Then we get premise 3, an objection, and that could be that what if the payoffs are different for different people? So Pascal starts with the assumption that we will all face the exact same decision problem, whether God exists or God doesn't exist, and we get the same results. So you can make the argument that there could be different payoffs for different people. So this could be, if you read about the many gods objection from the reading right after Pascal, there could be different gods. And one god could be this evil god that rewards evil for good. One god could reward good for good. There could be a bunch of different gods doing different things. In this case, Pascal's argument would not hold up, because it's dependent on there being an ultimate reward if God exists, an infinitely happy life. So you could also say, like, what if there's a God but he's not good? In which case this would fall apart as well. So hopefully this will help you be thinking of objections to, all kinds of arguments whenever we read. Then another possible objection is to just deny that the wager is valid. So you could say that these premises don't actually yield this conclusion. We won't go into specifics how that works because it's complicated. But it could be the case that the premises don't actually prove the conclusion, that the premises lead to something else. So it could, he basically just gives a bunch of different ways that Pascal could be wrong. And then he ends with, maybe Pascal is actually ultimately smart and he was right all along. Because unless you assign 0 to all of the premises as the expected utility, unless you do that, his decision theory matrix will always work. So you have to be 100% sure that there's no chance of any of his premises occurring. Because if there's even the slightest chance of each premise, then his argument succeeds. So it's almost like he has the final say, which is really interesting. Hayek says, what's your alternative to Pascal? To assign probability 0 to his premises all being true? That seems like an extreme form of dogmatism, because you have to be 100% sure in 0, unwarranted by your evidence. To be sure, we have seen various ways of questioning the premises or of arguing against them. By all means question them, argue against them, but can you really justify giving them no credence whatsoever given your evidential situation? So he says that as much as Pascal's wager kind of invites questioning or arguing, unless you give absolutely no credence to any of what he's saying, his argument works. So, it's an interesting way to look at it. So he doesn't really end with like a strong argument for or against Pascal. He's just kind of chose a different way to explain what Pascal was doing and different ways that Pascal could or could not be wrong. So that's a way that you could write a paper. Anyways, so yeah, that's about all we have for this time. So Tuesday you'll have your paper proposal due, and if you so choose, your critical summary. So be sure to do both of those if you'd like, and just turn them in at the same time, and we'll get it figured out. Let me know if you need anything. Let me know if anything's confusing, if you're having a hard time. I think that's all I got to say. So have a good weekend, and I'll see you later.